line. Okay, so anytime you plot data and you draw a line that you think fits the trend of the data, it generally follows the data. You've drawn a trend line, okay? And so you can write the equation of that, and that is a trend line. Everyone could have a different trend line for the same data, because if you drew your line at a slightly different angle, we are human, okay? And so they would be slightly different. If we all come up with the best trend line, the reason it would be called the best is the points would actually be closest to that overall. So something the calculator does is it calculates these things called residuals. And residuals is when you draw your trend line and the points are kind of surrounding it, how far are they from the line? The goal is to adjust the line's slope and y-intercept so that it creates the least amount of residuals, right? The least amount of distance overall between the points. And I'll show you another way to look at that in a little bit. So on a calculator, it will calculate the least squares regression, which is like calculating the least amount of residuals. So it won't come up with a trend line. It will come up with the best trend line. Does that make sense to everybody? Okay. So first, you need to put your data into your calculator. This is a statistical operation, so that menu is found in the Stat button of your calculator. So we're going to press Stat. Okay. And then we're going to go ahead and go to Edit. Okay? We'll wait for people to grab calculators. That you and the person next to you need one, because we don't have enough if other people don't have one yet. So if someone already has one, okay, right next to you, then we'll share for now. Okay. So we've pushed the Stat button. So again, if you guys are taking an exam and it asks you to come up with the regression line or the line of best fit or the best trend line, you're going to do these operations on the calculator. So you have to be able to do them. So we're going to go to Stat, and the first thing we're going to do is Edit, because that's how we create a list. Okay? So we're going to press Enter on Edit, and it's going to bring up these lists. Now, these calculators, if you're using one of mine, are used by a lot of people. So be aware, my lists say L1, L2, L3. Some people have deleted certain lists, so yours might not say L1. You need to know where you put your data, okay? Second thing, there's already data there, and I don't want that data. I'm going to scroll to the very top of the list on top of its name, L1. Don't push anything for a minute. I'm going to clear the list. If you press Delete, you will no longer have an L1. Do you understand? But if I press Clear and I press Enter, it will just take all the data out of L1. If I press Delete, L1 will go away. I won't know where it went, and now I will only have L2 and on available for me. If yours already has L2, it's fine. You're going to put your data in L2 and L3 instead of L1 and L2, but you'll see why that will pay attention later. So you need to know my X values are here, my Y values are here. Okay? All right, so our X and Y values are our number of bites and how long our licorice is. So let's see. Conrad, just because you're sitting right here, you can be my guinea pig. Okay. So if I'm Conrad and I ate my licorice and I have his data right here, he has up to 8 bites. Okay? So he has, when there was 0 bites, 1, 2, 3, 4, 5, 6, 7, 8. Not all of you will have 8 bites, and that's okay. You only want to put in the number of bites you took. Then I'm going to arrow over to the right so that now I'm entering data in list 2. With 0, he had a licorice length of 16.5. Then 16.2. Then 15.3. Then 14, 12.9, 12, 10.5, 9.3, 7.3. How come it never goes to 0? Oh, you have more bites. Okay. You took a lot of bites. He eats little bites of licorice. Okay, so 9 is 0.54. Or is it 5.4 or 0.54? 5.4. Okay. And then he got sick of taking little bites. Okay. Thank you. All right, so here's a bunch of data. You guys made a scatter plot. The calculator can make one too, but you have to know the right stuff to turn on. So the first thing that we're going to do is we're going to go find how you turn a scatter plot on in the calculator. So these are the graphing buttons, remember? Scatter plot is a kind of graph, but again, these are statistical operations. So we're going to go into this stat plot menu right here. So we're going to push second and y equals. And you see a bunch of plots. Okay, there could have been things done to them. We don't really want any of them on at this moment. We're going to go turn one on. So I'm going to go into one of them. It doesn't really matter which one. I'm just going to go in the first one. I need to turn it on, and I need to tell it what I'm creating. So I need to turn it on instead of off. So I need to press enter on top of on. Then down here in type, I'm creating a scatter plot. That's the first type of graph. Somebody else was using this for a bar graph. I don't want that. Okay? So I'm going to make sure I press enter on top of the scatter plot image. Then it asks me for my X list and my Y list. You need to change the list names. This is very important. It's like the minus and the negative sign. If you need to change the list names and you just go type in an L yourself and a 1, it's not going to know what you're talking about. It's not that smart, okay? It doesn't know that every time you type L1, you're talking about list 1. You have to actually go get something that the programmer that programmed the calculator to know that is the list 1. So if you'll notice next to the letters that are in green, okay, in blue there's things like L1, L2, L3. Those are the pre-programmed list names. So if you are using a list of data, that is what you should type in there. Mine are already set correctly. My X list was my L1 and my Y list is my L2. Okay? And then the mark is just like, how is it going to mark the points on your graph? The little dots are really small, so sometimes it's better to use the pluses or the box because they're a little easier to see. Okay? Now, you might think, got it, done, press graph. What the heck? Okay, so what's going on with mine? Two things. It's not zoomed correctly. Look at the graph on your paper. Okay? Me and Miss Brady found the right graph for you to graph your bites of licorice and length and all of this kind of stuff for the most part. All right? This graph has not been set in any way, shape, or form. And then it has this other absolute value function because we were playing with that the other day going through it. So just some like aspects of using the calculator. If you have other things showing up in your graph, go to your y equals. The reason other stuff is showing up in my graph is, see, I still have the absolute value of x turned on. When that equal sign is bold, it means it's turned on and ready to graph it. So I can either clear that equation out, or I can simply scroll down to it. Maybe I need it for something else later. Press enter on top of the equal sign and just make sure it's not bold anymore and it won't show up, but I can keep the equation there if I need it for something. Okay? Notice the other bold thing is plot 1. I now want plot 1. It's bold because I went and just turned on a stat plot, right? That's telling me that that's turned on. So I've taken care of the random graph that was going through there. The next thing I need to do is I need to zoom for my data properly. So I can do that by hand, or the calculator has a wonderful feature that if you're using data, it will zoom it for you. Okay? So if we go to the zoom button, and last time we chose 6, that was the standard 10 by 10. That's not what we want now. If you scroll down a little further, you will see number 9 is zoom stat. That's what we want. So you want to press 9 or scroll down to it and press enter. So here is, okay, a graph of Conrad's licorice bites. Okay? All right, so you guys took that data. You drew your own trend line on the paper. So this should match what you have on your paper. It might be zoomed slightly differently, but same idea. You guys then drew a line and wrote the equation yourself. We're going to let the calculator now calculate the best line for this data. Okay? And then we're not going to use the data points anymore. We're going to use the equation the calculator found for us because it is the best estimate of what's happening all of the time. Okay? So we're going to go back to that stat menu. But this time, instead of editing, our lists are good as they are, we're going to be doing calculating, okay? So we're going to scroll over to calc. The line that we're calling, okay, is a least squares regression line. So notice all of these choices that have REG next to them, those are different types of regressions that are shaped like different type of mathematical curves. We are dealing strictly with lines right now, so we're going to go ahead and do choice 4 because it is a linear regression, okay? So either scroll down to choice 4 or just press 4. And depending on how old your calculator is, one of two things will happen. If you have an older one like mine, it'll look like this. If yours doesn't look like this right now, just hold on, okay? If you have an older one like mine, it looks like this, and you need to tell the calculator where your data is. So you have to say, I am using list 1 for x's, comma, list 2 for my y's, and then we're going to do something special here. It's going to come up with an equation that might have some really strange, like never-ending, non-repeating decimal values in it, and I don't want to have to copy those later to have it show up on my graph. So the third thing I'm going to do is I'm going to tell it that when it comes up with this equation, I want it to automatically put it into my y equals in my graphing area of my calculator, so it's already there and I don't have to retype it, okay? So after this, I'm going to put another comma, and then I'm going to tell it which y equals I want to put it in. So the place you find that is right here in the variables button, vars. So we're going to go vars, y vars, function, and then you just choose what do you want it in, y1, y2, y3, y4. I'm just going to choose y1, okay? If your calculator did not look like this, it came up with a much more explanatory window where you get to type things in that you want, and it has little directions for you guys, which is much nicer. So the first thing it says is xlist, and in mine we would use L1. Then it says ylist, and you would use L2 or whatever. Then below that it says frequency of the list, just leave it blank, okay? Below that, it says store reg EQ. So this one, the frequency, we don't care about, okay? The store reg EQ. Where do you want me to store the regression equation? See, in the old calculator, I just had to know that that's what it wants to know at that spot. In the new one, they're saying, now type where you want to store it. But you guys want to go get the Y1 just like I did. So you want to go right here, and you want to go to vars. Okay, and then you want to go to function. It's your first choice. And then, y, scroll over to y vars. Here, I'll do it again. If you already did it, don't do it again. But this, over to y vars, function, y1. Okay. Now, yours has a calculate. Okay, scroll down to calculate and press enter. Those of you with old software, just press enter. So Conrad's best line of fit is this line, y equals negative 1.468x plus 18.195. It's data, okay? You got to remember, data is not perfect. Look at Conrad's bytes. They weren't linear. Sometimes he took smaller bytes. Sometimes he took larger bytes. This is just generalizing the process, okay? But now Conrad's going to use that equation to answer the questions in numbers 4 through 10, okay? Once you have data, let's say I took everyone's height and shoe size in here, right? And then I drew a line. If someone says, okay, you need to go buy a pair of shoes for a 15-year-old boy, I would have a lot of data for 14, 15, or 16-year-old boys if I asked all of my classes. Now, some of those 14, 15, or 16-year-old boys might wear a very small shoe. Some might wear a very large shoe. So I can't base it off of that. What I could do is collect all the data and draw the line that best represents it, and I would rather plug the age into my equation and get it. So after you've gotten an equation, you're never going to go back to using the exact just little pieces of data unless they ask you something about the original data. From now on, if they say predict, What's the slope? What's this? You're using this equation because this best fits your data at all of the points. Does this make sense to everybody? Okay, so everyone's going to need to get an equation from the calculator for their data. There's a way to do this on Desmos, and I'll tell you more about that because when you do the video tonight, you can watch an extra one if you want to use Desmos at home to do some of this stuff and see how that works. So everyone needs their equation, and then you guys are going to go on to answer numbers 4 through 10. Okay? Yes? Mm-hmm. I'll come help you individually. Everybody understand that you're working on 4 through 10? Yes? So you need an equation, and you're working on 4 through 10.